Welcome to our class of data analytics. Today we're going to talk about SDLC. As we are starting a digital age, data analytics has become an essential skill needed in a lot of fields, especially for students who are pursuing technology. Understanding the SDLC or software development circle is crucial, and within requirement analysis stand as a paramount phase. The stage, the first stage on the software development life cycles is on the picture here is planning, but we call it the requirement analysis phase. And this stage lays the foundation for the entire development process. Why? Because this process ensures that the needs and expectations are accurately identified and documented. Okay? How we gather the information necessary, what the company needs, all the information, what they want, they expect us to analyze and to investigate what happened with this area. Is the required analyst is essential role for the process, providing direction and focus on what we need to analyze. Even developers need to understand these software development life cycle steps. We're gonna guide you through the fascinating landscape of requirement analysis in the software development life cycle. Okay? We're gonna talk about what is the requirement analysis. This is important to have a good communication with the customer while asking for the analysis of their business. Let's define what is required analysis. What people do when they are doing requirement analysis. They work closely with the stakeholder in a project to identify and document the specific needs and requirement of a product. The responsibilities that are involved is electing the requirements. What we mean with that, they interact with stakeholders, users, and project team members to gather and understand the functional and non-functional requirements of the system. The first step. Second, analyzing requirements. They analyze the collected information to ensure that the requirements are clear, concise, and free from ambiguity. Okay? There's steps that you need to do when you are doing requirement analysis. Documenting the requirement. You have to create formal documentation that over there you're going to outline the requirement in detail. You need to use model diagrams and formats. Step 4. Validating and verifying requirements. They work with stakeholders. That's what you're going to do. You're going to work with the client to ensure that the document requirements align with the business needs. And you can achieve this in the time frame that the company gives you. Step 5. Managing the requirement. You have to know how to manage change to the requirement. You need to evaluate this change, document it, and communicate the change that you are doing and why to your development team. And the step 6 is facilitating the communication. Okay? You're gonna be the bridge between the technical team and the business stakeholder or your customer. And you have to make sure that both sides understand the requirement analysis and uh, is develop a system why they meet the needs from the analysis of this business. The requirement analysis is going to be this requirement on the analysis are going to be the one going to shape the direction of your project. And this requirement analysis, they're going to make sure that the final product that you're going to give to your customer align with the expectation and the need of the business or the users. This is the base for create a successful development. How you implementing this and how you deliver. You need to with the requirement analysis, then you set up the base to know how to develop, how you implement, and how you deliver this system or product that you're gonna give to your customer or business. Now we're gonna talk about the design phase. After the requirement analysis that we collect information, we talk to our client or businesses or business and what we want, how we want it, what we want to happen. After all that, we're gonna do the design phase. The design phase focus on how you translate this requirement and how you translate it and turn it into a blueprint. For for this blueprint is going to be used to build the software. And the design phase have 7 steps. The first step is called the architectural design. Is a is a step that involves that you create a high level design of the entire system. How you gonna create this design? You need to define the main components on this design. The relation of these components and the overall structure of your design. Okay, you're gonna give them a view of how this system is gonna work and how this system will interact with other systems. This is what the first step, the architectural design is gonna be. Okay, you're gonna give them a view of what you're doing, why, what you're gonna have on this software, what the relationship of this component that you put on the software, and the overall of the structure and how this work, how you're gonna give them the architectural design. The second step is the detailed design. Here you're gonna go more deep in details of each component. You're gonna give a definition to your customer or business how this component work in a functional level. What you include on this detailed design, you need to include uh, is how designing. You have to include designing your data structure, your algorithms, your interface design, and other stuff. What the important of the detailed design is that it's going to help the developer to understand exactly why they need to build. They need to understand why what they need to build to satisfy the customer or the business. The third step is the user interface design. What is this step means? This phase is what you're gonna do is creating the interface uh, through which your user will interact with the system. Okay? You're gonna focus on the usability, the accessibility. In plain words, you're gonna focus in how the users interact with the system, what the experience of the users. Okay? This involves mockups and prototypes. Okay? We focus in the user, the experience of the user with your system, the system that you are creating. The fourth step on the design phase is database design. We know the system is going to require a database. Okay? How you design the structure of the database. In this structure, you have to include tables. If you are in data analytics or data science, you know about relationship, how you can create a relationship between tables, keys. It's all about the database structure. Okay? When you do this phase of the database design. Now, the fifth step is documentation. You need to create a proper documentation for the entire design. And you need to give your customer business a comprehensive guide for the developers so they can follow uh, this guide during the construction phase. Are you going to include over there flowchart, data flow diagrams, entity relationship diagrams, and any other visual representation. Those are your documentation. Now, sixth, design review. Before you move to the design tools, you need to make a design review. You want to give this review to the customer, the stakeholders, the architect, the developers, to make sure that all of them agree with this design, with the requirement, and if it's feasible for development. Okay? To make sure everybody agree what you did is what they want. And what you did is uh, real to develop. Okay? Because you can make this wild, wonderful architecture design, blah blah, but what the developer can do. You need to be real, what you can do, what you cannot do. And the final step is the design tools. Okay? This is when you use the case tools or the computer aided software engineering tools. These tools are going to make easier to create, visualize, and modify the design. This phase, the design phase on SDLC, or System Development Cycle, is vital. It's vital to ensure the system architecture is robust, scalable, and aligned with the project requirements and contracts. This design phase is going to set the stage for the actual coding and development of your system. It's a roadmap, a guide for the developers. We're going to help them through the construction phase. Okay? A very important uh, phase on the system development life cycle or SDLC. Now, I'm going to give you examples of the case tools that we use on uh, the design tools. Some examples are modeling language or UML, the Erwin data modeling, the Microsoft Visual, Start UML, and the most used one and probably the one that you hear more is the Jira. Also, we have the Apache subversion of SVN, the IBM Engineering System Design Rhapsody, the Smart Draw, and the Azure RP. Also, we have the Spark Enterprise Architect. You use it depending on the functions that they have and how these can assist on the task designing, analyzing, coding, testing, uh, doing project management, documentation. The one that we use here is the JavaScript. Okay? And why we use this? Because these tools are going to help us to improve the efficiency, accuracy, collaboration, and the quality of your software development process. After the system design, we're going to talk about the develop design, develop interface, sorry, on SDLC. On the software development life cycle, we have three roles. The first one is the product owner role. Second, the project manager role. And the third is the technical lead. What the product manager, the product owner do? The product owner is someone who represents the business and is the voice of the business or the stakeholders. And the product owner makes sure that the development of the project is done according to the project requirement that the stakeholders give. Okay, it's not the product owner doesn't mean is the owner of the company. It's someone that they choose to be the voice of the company and give the guidance of how they want or what they want to achieve with the software. The project manager, who is the project manager? The project manager is the one who represents the team. They coordinate the work and organize meeting and negotiations. That's very important. Well, usually the project manager is the one who decide uh, which method they're gonna use to complete the project. And we have the team lead. Who is the team lead? The team lead is the one who is focused on the technical implementation and they give advice on how to translate the idea into technical solutions. The one who represents all the people who the software, the technical people, like the software engineer, the data analyst. He represents all of them. He makes sense between the company idea of people who are not familiar with technological stuff. He's the one who can uh, bond technical with idea because at the end they can drink all they want, the owners, but the reality is what the software development team can do. So these are uh, the description of those positions. Let's talk about the role that we are interested in, the uh, business analyst role. the requirement analysts, what they do, what they first, this person needs to work closely with the stakeholders. They want to be in charge to identify and document the specific need and requirement of a system or product. That's the first thing. Which responsibility this role gonna have? The first one that we talk is interact with the stakeholders, the users of the software, and the project team members. We need to uh, gather information and understand the functional and non-functional requirement of the system. Another responsibility that the data business analyst gonna have is collect the information and make sure the requirements are clear, concise, and free of ambiguity. Third responsibility is going to be create formal documentation that going to outline the requirements in details. How they going to do that? Using diagrams, format models, four things that they need to do. Work with the stakeholder to make sure the requirements are aligned with the business needs, and also that you can achieve those. The fifth, the responsibility number fifth, they need to be able to know how to manage change of the requirement. They need to evaluate properly the change, document them, document them, and be able to communicate those change with the development team. And the last responsibility is they are the bridge between the technical team and the business stakeholders. They need to make sure that both sides understand the requirement and the development team uh, meet the needs of the business. That's very important in connect both. Also, is a vital role in shaping the direction of a project. This way they can ensure the final product. They are the key for a successful software development lifecycle. Welcome back again. We're gonna talk about design phase now. After the requirement phase, where we collect the information necessary about the business and what the stakeholder or business owners they want to achieve, we go from the requirement phase to the design phase. What is the design phase? Is when the requirements are represented in a form that is suitable as per customer demand. and they can be easily implemented through any coding language by the software development team. The design phase is one of the critical stages in software development. Why? Because with the design phase, we're gonna focus on translating this requirement on blueprints. These blueprints are needed to build the application. So we got the data analyst is gonna give analysis to the development team. Then uh, from there we go to the uh, how quickly create the application. We go to the architect, and this architect are gonna create blueprints. Is we're gonna construct? It's like is we're gonna is a sample is when you construct you do a construction of a building. Before you construct this building, before you constructing this building, you need a blueprint that the architect give you of how has to be constructed, because you cannot go there and put cement and uh, without someone who is studying how to do it properly. So this software development team or the architect, they create a software design. After the design, they're gonna go into coding, and after the design, it comes the implementation phase. When you are designing the software, you have two different phases. They are the preliminary design and the detailed design. The preliminary design is a rough design of the software by several uh, software designers, and this design is according to the customer requirement. So on this phase, phase, you're gonna have more than one design, and you're gonna start uh, evaluating this design, see what reject the design and how to modify the design. And after test all these design, you're gonna decide which one is the right for what the stakeholder or customer needs. After you finish the preliminary design, it comes the second phase, the detailed design. And this is the final design that is made in the preliminary design phase. After you made the design, you not gonna have future change on this design. So this design is gonna be sent to the development team. So they're gonna evaluate on every manner before finalize this design for the software that they're going to implement on the project. So we had the architectural design phase, that is the first one, when uh, we create and design the entire system. Here you're going to define the main components, the relationship, and the overall structure of the software. You're going to provide a bird's eye view of how the system will function and interact with other systems. Another step is the detailed design. Here in this stage delves into the finer details of each component, defining how they will work on a functional level. It's going to include designing data structure, algorithms, interface design, and after this, you have other steps that, depending on the uh, field that you're working with, is going to be required. With these detailed designs, you're going to help the developer understand what they need to do. Give them this detailed design, and the developer going to have the idea of exactly why they need to do. The user interface design is about creating the interfaces through which user will interact with the system. You're gonna focus on the of the users, the people who are gonna use the software. Why is that usability, accessibility, and all the user expectations? This expectation involve mockups and prototypes. After we finish the user interface design, we walk to the database design. Only if the system needs a database. You wanna, in this stage, you wanna design the structure of the database. You wanna include tables, relationship keys, and any other relevant aspect depending on the company and the wishes of the stakeholders. From there, we go to the documentation. You want to document everything that you are doing on the design of this software. This is where you provide a comprehensive guide that the developer can follow in the construction phase. You want to include flowchart, data flow diagrams, entity relationship diagrams, and any other visual representation that you can provide. After this, we pass to the design review. The design, it has to be reviewed by the stakeholder, the customer, the architect, and the developers. This way we're gonna make sure that what we're doing align with the requirement that they want and is uh, is real, and you can uh, it's gonna be feasible for the development. So the development team can do it. You can, like I always say, you can dream all you want, but if the development, the software people, they don't know how to build that software because all the dreams that you give them, then oh, it's not gonna work with this. After that, we're gonna go to the last step that is design tools. Tools that gonna be used to assist the design phase. These tools are gonna make easy to create, visualize, and modify the design. A sample of this is the computer-aided software engineering or CASE. Remember, in this design phase where we do these 7 steps, it's vital for you to ensure that the system is robust, scalable, and aligned with the project requirements. Because when you do that, is the way that you set the stage for the actual coding and development of the system. It's a roadmap to design. It's a roadmap for the developers. Right? Let's talk about. Hmm? We talk about case. That is the software. Is the tools that we use to assist in the software development process. What did two case do? The computer aided software engineering. With this, you're gonna automate some tasks and simplify complex process. This tool you can use it in different stages. Some of the samples of case tools are rational rules. This is a popular object-oriented modeling. It helps creating use case, sequence, class, and other diagrams. If you want, you can use as a sample UML, Unified Modeling Language. You can look on Google information about this and have a, a little example of how it looks and how it works. The second example that we have is the ER-Win data model. This, as the name says, is focused on data modeling. And this tool allows you to design and manage complex database supporting various database systems. The third one that we have is Microsoft Visio. Usually they use this to create various types of diagram and flowchart. It will include process diagrams, organizational diagrams, and network diagrams. Another is Start UML. It is an open source tool of UML. We have the Unified Modeling Language and we have the Start UML that is our open source. And they support diagram and provide extensibility through plugins. The one that is most used by data analytics is Jira. It's known as a project management and bug tracking tool, but it's a case tool because support various aspects of software development. It's going to include the required management and collaboration. This is the most used in data analytics. We have the Apache Subversion or SVN. This is a version control system that help you in managing change to source code and other documents over time. Another example is the IBM Engineering System Design Rhapsody. This one is a visual development environment that supports model-driven development with UML, SysML, and other modeling language. It supports other modeling language. We have the Smart Draw. This one make easiest for you to draw flowchart, network diagram, org chart, floor plans, and another design related diagrams. We also have the Azure RP. This one is used for wireframing and prototyping. This allows the designer to create interactive prototypes for web and mobile applications. And the last example that we have is the Sparks Enterprise Architect. This one supports UML, SysML, BPM, and other notation for modeling, simulation, design, and construction. This case tool is going to be used depending on the specific function and can help you in different tasks like design, analysis, coding, testing, project management, and documentation. And this tool help the development team. Now, what is the implementation phase in the SDLC? This is the stage where the theory and plans transition is transformed to actionable insight and tangible results. It's not only about coding, it's about how you translate the design, the designer blueprint that the architect gives you, and how you translate this into a working process. Now, there are steps that you have to follow on the implementation phase. The first one is coding and development. Where in this step, you're going to transform the raw data into meaningful information. This way, you're going to take the refined requirement that the stakeholder or customer give you or clients and the design, and you're going to create the actual software. Those design specifications are translated into source code using the appropriate programming language, frameworks, and tools. The second step is integration with data. This is when you integrate those implementation with the data source. You're gonna develop algorithms and you're gonna set up data processing pipelines. This is about we're talking about how you align the software with the data driving goals of the project. And you have to ensure that this can handle the process and uh, you analyze the data in the efficient way. The third step is testing. You have to have a rigorous test uh, of this data analytics that you're doing. You have to test these models against the unseen data. In this step is when you take various testing methodologies and employ them to ensure that the code meets the desired functionality and the performance standards. And you have to maintain the integrity of the data and the system. Okay? And the last step is the optimization. I'm sorry, the fourth step is optimization. Here you must like fine tuning a machine learning model. Then the code may be refined and optimized during this phase to enhance the performance and efficiency. And here you have to include optimizing queries, improving the data handling, and you have to make sure that the software can scale with the increasing data volumes. The more data, you have to make sure the software can handle how you optimize the software. The fifth step is the documentation. As usual, you have to document every implementations that you do. It's gonna help future developer understand what you did. They can understand the structure, the functionality, and the purpose of your code. It's very important that you document what you do. So in future development, they can understand what you did and how to improve what you did or what need to be changed to keep your software in healthy way. And the last step that you do on the implementation is deployment. You see, when your code is ready to deployment, and it's gonna go from deployment to a production environment. And here you have to check the data security, scalability, and reliability. And you have to make sure that this software can support real-world data analytic applications. Okay? For you as data analytic, you're gonna see the implementation and a bridge between a theoretical design and a practical data-driven solution. Here, all your algorithms, algorithms come to life when you see everything. Where your data pipeline are constructed, and you want to show how your software become capable of providing the actionable insight. This is the way we can see how the software is much like the analytical model. It's much like the analytical model that you may be using to work. So implementation is how you see your code working. Now we're going to the next phase that is going to be the testing. Now we are on the next phase that is testing. What we do on testing, you're going to validate your predictive models and you're going to make sure that this model is reliable, accurate, and is going to be capable of performing under real world conditions. You want to test your software. Which one are the steps on testing? The first one is the unit testing. What we do here, we're gonna examine all the variables and features that we put on our data analysis. You're gonna look at the small details on your software. You're gonna test individual functions or method installation. And you want to make sure that each component is working correctly. That's what you do on the unit test. The second step is going to be the integration testing. It's similar to examining when you examine different data sets or how the future interact in your data analytic context. What we look on the integration testing is how all these components of the software work together. How they work together and how they integrate each other. The third step is the functional testing. Okay? What we do here, we're gonna make sure to verify that the predictive model is gonna achieve the, the purpose, the intent purpose. And this functional testing is going to help you confirm that your software behaves according to the requirements that they give us. Okay? The fourth step is the performance testing. What we do here, you want to evaluate how the data model performs. And you're going to evaluate how your data model performs with different data volumes and conditions. With this performance testing, you're gonna check how your software behaves on the different loads and stress. And you're gonna focus on the responsiveness, stability, and scalability of your software. Now the fifth step is regression testing. What we do here, It's very similar to the re-evaluation when you re-evaluate your data model. Here you can introduce new data, and this regression testing is gonna uh, ensures that this new change or addition that you do on your software don't uh, interfere with the existing functionality. Okay, that's what you do on the regression testing. The next step, uh, oh, I forgot before regression testing. Sorry, before regression testing, I did a mistake. The fifth was the user acceptance testing. User acceptance testing, or UAT. This is the user acceptance testing. Let me change this. What are you gonna do on the user acceptance testing? Here you want is like you validating uh, your analytic insight with the stakeholder. Here you're gonna be working with real users who gonna test your software in a real environment, in a production-like environment. And this is to make sure that your software meets the user expectation and of course the business objectives. You have to make sure those are satisfied. Now, in the seventh place, we have the seventh step. We have automation. What we do in this step? This is a key role for software testing and data analytics. Here you're gonna execute repetitive tasks to improve efficiency and accuracy. The same way you do in automatization data processing and analysis in analytic project. Okay? The eighth step is the quality assurance. Always quality assurance is important. Ensure that uh, your final projects is free from defects and of course align with the requirements and standards. This is a very rigorous validation that your program is software is reliable. So it is the last step on the testing phase for software development life cycle. And the testing is very important to build confidence in your software and give satisfaction to the stakeholder or your customer or uh, the business that you're working with. Okay, and now we're gonna talk about one of the final stage of the software development life cycle, and this is the deployment. What we do on the deployment phase. This is where you software is going to be available for the end users. Which are the steps on the deployment? The first one is the preparation for deployment. What we do on the preparation for deployment. First thing we do is the environment setup. You have to prepare an environment to put this way you can host the software. Okay? And this environment has to mirror the testing environment. The second is configuration management. What we do here is when you set up all the configuration, including database connection, API endpoints, and any other environmental variables. And the last step that you do here is the compliance check. What we do on the compliance check, you have to make sure that you comply with any regulation or security. Okay? You have to make sure that you comply to all the or any regulation and security compliance. This is the first step on the deployment. A, B, and C. Now, what's the second step? Let you know which one is the second step in 1 second. Like in here, just look. Okay. Number two is the deployment strategies. Deployment strategies. The first thing we do on the deployment strategies is the manual deployment. What we do on the manual deployment? is when people intervene to transfer and install the software on the system. How we do on the manual deployment. The next is the automated deployment. What we do here is it when you reduce human errors because you're gonna use tools and scripts to automatically deploy your software. Okay? The next step is continuous deployment. Well, who is actually what we do in continuous deployment is when the DevOps approach. So they're gonna uh, take the code commute that uh, pass the automated testing and they deploy into the production environment. Okay. The next step is the blue-green deployment. What this deployment is gonna mean? That you're gonna have two production environments. To, to, those the blue and the green you can switch between each other, and this gonna enable you to do seamless update, and it's gonna make you uh, easier to roll back in case of any issues with your software. Okay? That's like the step on the deployment strategy. After that, we're going to release. What means this? I'll explain you in 1 second what this means. What we do when we release. First, version control. What we do when we do a version control. You're gonna keep track of different versions and ensure that updates and change are managed efficiently, okay, and effectively. That's what you do on the version control. The next step you're gonna do is the deployment. This is a very famous word in the software development life cycle, deployment. What we do on the deployment? You see, when your software is going to be installed, it's going to be configured, tested, and they're going to put in operation inside the production environment. That's what you do on this step in the release. After the release, you're going to have the monitoring. What we do on the monitoring? Mhm. So you're going to monitor it. constantly to detect and address any issue that your software has. Okay? Constantly monitoring your software and to detect any issue, any defect in a promptly manner. What the next step on deployment stage from software development life cycle of SDLC? Next step is post deployment. What you do in post deployment? First step. What we do on the post deployment? First thing, user training, of course. And not throw the software over there and expect that the user gonna know what to do. They don't understand nothing. The end user gonna require a training. Or provide you need to provide them a documentation so they can understand how to use your new software in the right way. After that is the maintenance and support. Of course, you're not gonna let your user alone. You don't want them to mess up your software. Hmm? So you have to go on an ongoing support. On this support, you're gonna uh, deal with the bugs, security patch, or any necessary update that your software needs. Now, the last step on deployment is the last step on deployment is the rollback plan. What do we mean with this? That you need to have a plan in case some critical issue arise, and this rollback plan is have to revert to a previous stable version of your software. That's what we mean on the rollback plan. The software, you need to have a backup plan, something to fix whatever issue. You can reverse to the previous version, stable version, the best version. In other words, the deployment phase is a bridge between the development environment and the end users. Is where your software is going to be available to the public or a specific set of users. And this phase you're going to require careful planning, coordination, and execution so you can ensure that the software is not only successfully deployed but also maintains performance, security, and reliability in a real world. Okay, we made it to the last step on the software development life cycle, or SDLC. It's called the maintenance phase. This one don't stop. This is as long as the software is in use, you're always gonna have to stay on the maintenance phase. Why? Because this phase is crucial to ensure that your software is gonna keep meeting the user needs and functions. and function properly. Okay? What involves the maintenance phase? Let's talk about that. One, corrective maintenance. What you have to do in a corrective maintenance? Fix it, fix it, box and error, box and error. So sometimes after you deploy your software, you're gonna find bugs and error that they appear after the user uh, or the person who gonna use them use it constantly. Those bugs and error are gonna start appearing. Other thing that you have to do in the corrective maintenance is updating the code. Or it's very important. It's the first thing they tell you when you want to learn software development or data analysis, anything that has to be with coding. You have to keep updating because every year, every time we have new uh, feature on coding, a new way to do faster and more efficiently. So you have to keep updating your code to correct issue, and then you have to make sure that it's functioning correctly. The second step on maintenance is the adaptive maintenance. What we mean with the adaptive maintenance? First point, adapting to changes. Of course, you have to update the software to make him work with new operating system, hardware, or change in any other integrated system. You need to make your software adaptable when you change. And the next point on adaptive maintenance is compliance updates. Compliance update. What we mean with the compliance update? You need to make sure that your software continues to meet regulatory and legal requirements. And but the same way the software you change uh, stuff on the code, you have to make sure that those change meet regulatory and legal requirements. Okay. Third step on the maintenance phase is the perfecting maintenance. What we do here? First, we have to anticipate change. Sorry, issues. Do you anticipate issues? You know that we talked before. You need to keep monitoring your software. You need to keep analyzing the software. You need to catch future problems that you can identify, and you have to address those problems before they become critical. Okay? You need to anticipate issues that can happen with your software. Very, very important. Okay. Next, documentation update. Update. What you do? Eh? You need to keep your documentation up to date and make sure that this documentation work on the software. Why? To future understand in the understanding of the structure and the functionality of your software. You need to keep updating the documentation about the documents, uh, updating the information of your software. Now, after we do perfecting maintenance, we have the four step, okay, that we have to do. It's called the preventive maintenance. Of course, preventive maintenance. What we do here, first, ongoing monitoring. Okay, keep saying the same thing. You have to keep monitoring your code, your software. Code too. You always have to observe how your software is acting, so you can detect any issue and fix it early before your software is a mess. Okay? Preventive maintenance. You need to keep checking your software, checking your code, and then user support. Preventive maintenance. We need to do user support. How we do? Help desk, FAQ, or direct interaction. You go to them, you talk to them, you review how everything going, it's working for you, it's doing the work. Very important that you keep an eye of how your software is doing directly with the user. The fifth point on the SDLC maintenance phase, our last phase, is monitoring and support. We keep saying monitoring, monitoring, monitoring. Oh no, sorry. We thought they want this is the monitoring support, and now the preventing support. Sorry, this was the monitoring support, and now the preventive support. Preventing maintenance. Preventive maintenance. What we do on the preventive maintenance? Of course, the first thing we're gonna do is anticipating issues. Anticipating issues. How we do that? You continuously monitor your software. You analyze the software. so you can identify an address future problem with your software. Uh, I think I made a mistake. Uh, mistake. This one, this was the preventive maintenance. Okay, I put perfect. Yeah, this is the preventive maintenance. We talked about this already. This is the one we haven't talked about the perfecting maintenance. In perfecting maintenance, we're gonna improving performance. How we do that? You have to optimize the code, upgrade your libraries, and any other action that you could do to improve the efficiency and responsiveness of your code. How your code responds, you have to make sure to monitor it the way. And second is enhancing functionality. How we do this? We're gonna add new feature, or you're gonna improve the existing one. This way you're gonna enhance the user satisfaction and you're gonna keep your software competitive. Okay? Now the sixth point that we have in the maintenance phase is retirement planning. Okay? What we do on the retirement planning? First, what we're gonna do? Phasing out. Here is when you decide you have to retire your software. Maybe it's obsolete, maybe it's coming a new system that's gonna replace it, or any other issue that the team decide that the software is not useful anymore. Other thing that you do when retirement planning is data migration. What we do in data migration is when your software is being replaced. So you need to have a plan to how to migrate that data that you have in your old software to a new system without a loss or corruption of the data. That's what you do. So these are the six uh, way, the six point that involve the maintenance phase. So the maintenance phase is essential for the long-term success of your software. You're not only fixing the software, but you have to actively manage your software, improve your software, adapt your software, and potentially you have to expand your software to meet the evolving user needs. Or for you have to do it because regulatory requirements or new technological landscape. And this requires from you to have ongoing commitment, uh, keep collaboration with teams. You have to careful planning what you do with your software. And if you don't have an effective maintenance of your software, no matter how well you design or develop the software, if you don't keep a proper maintenance, this can be your software is going to become obsolete or unusable. Okay, what you have to keep, they tell you all the time monitoring, monitoring, maintenance. It's very important that you keep an eyes on your software to keep it relevant with the needs of the business that you're working with. Thank you for watching this video. Thank you for coming to my class and see you in the next class. Have a good day, everyone.